In this video, we'll look at graphing conics using polar equations. We'll identify the eccentricity, the type of conic, the equation of the directrix, and then finally sketch the conic. The first thing we want to do is manipulate this given equation in a way that will help us more easily recognize different components of the conic. And to do that, we essentially want this constant in the denominator to be 1. To do that, we can multiply the denominator by 1/5. And if we do it in the denominator, we need to do it in the numerator as well. So this will give us 4/5 divided by 1 minus 4/5 sine theta. At this point, we can see that this number in front of sine is 4/5. That's E, the eccentricity. And since E is 4/5 and the number up top is ED, we know right away that D must be 1. So we have eccentricity E is 4/5, and since E is less than 1, we can say that this must be an ellipse. When the eccentricity is less than 1, we're always going to be dealing with an ellipse. And notice that we have negative E sine theta in the denominator. That tells us that the directrix must be below the origin, or excuse me, the focus, which is at the origin. So with that in mind, we can start the sketch. We know that the focus again is at the origin, and the directrix is going to be below that. Again, because we have negative E sine theta in the denominator. And since D is 1, the distance from the focus is 1, we can say that this equation is y equals -1. That's the equation for the directrix. Next, we'll get some points to plot. Let's see what r is at the angle 0. So we're just going to plug 0 into this original equation. 4 divided by 5 minus 4 times the sine of 0. That is 4 divided by 5 minus 4. Sine of 0 is 0. So that is simply 4/5. So when our angle is 0, r is 4/5. So that point, 4/5, 0. And since we know some symmetry is happening, we can say that at the angle pi, r is also 4/5. Next, let's see what's happening at pi. Halves. 4 divided by 5 minus 4 sine of pi over 2. 4 divided by 5 minus 4 sine of pi halves is 1. So that is 5 minus 4 is 1. That's just 4. So at pi halves, we are up here. 4 pi halves. And now let's also do 3 pi halves. 4 divided by 5 minus 4 sine of 3 pi halves. 4 divided by 5 minus 4 sine of 3 pi halves is -1. So that gives us 4/9. So we're down here at 4/9, 3 pi halves. So our conic is going to look something like this. In the next example, we again want to sketch this curve. We will manipulate this equation similar to what we did last time. We want this constant in the denominator to be 1. So we'll multiply by 1/3 in the denominator and do the same up top. We have 2/3 divided by 1 plus 1 sine theta. From here we can see that the number out in front of sine is 1. That's our eccentricity. E is 1. And again, up top, this information is ED. Since we already have 2/3 up there, that means D must be 2/3. Again, 2/3 times 1, E times D will give us that 2/3. Note that when E is equal to 1, we have a parabola. Since we have plus sine theta in the denominator, that means that the directrix is going to be above the focus, which is at the origin. So we have the focus, and our directrix is going to be above that here. We know that's got to be y equals 2/3. The vertex is going to be between the origin, the focus, and the directrix. It's got to be in the middle, so that's going to be at 1/3, and the angle there is pi halves. And we are getting something like this. We've got a parabolic shape. Let's now find these 2 points on the polar axis. To do that, we can again refer back to the original equation. Let's see what's happening at 0. That'll be easiest. So when theta is 0, 3 plus 3 sine of 0. We know that the sine of 0 is 0, so we get 2/3. So this point is 2/3 0. This point is here. And since we know that there's some symmetry happening, the point over here must also have an r of 2/3, and that angle is pi.